Have you ever felt the moment that you have not enough time to study for the test? Even you have already sit, lay down, sit up straight again, sit with the cat, sit in the elevator, or even this problem will never happen again.
Sawadee-ka. Welcome to offline biomechanics course, with the topic is Review Biomechanics 1. In this topic, we will talk about the content in Biomechanics 1, about what you're gonna learn, what you're gonna understand, so you will be able to study. By showing you this following video clip, you will see the role-playing situation, and let's see how you can describe it related to biomechanics.
Kinematics is a branch of mechanics that describes motion in terms of position, distance, displacement, velocity, and acceleration. It consists of linear motion and angular motion. Linear motion or translational motion is where all the points on the body move the same distance, direction, and time, while the angular motion or rotational motion is where all the points on the body move at the same angle. Kinetics is the study of forces that cause the movement and the resultant energetics. It describes how forces and moments produce and change of motion of body. It consists of linear kinetics and angular kinetics. In the kinematics, both linear and angular, we have displacement, a change from initial position to the final position. It is a vector. It has magnitude and direction. In linear, it's symbolized by S with a row above it, with the meter as the unit. In angular, it's symbolized by theta. It is radians. It equals with arc length S over by radius R. Distance is the total length traveled from the initial position to the final position. It is a scalar. It has magnitude but not direction. In linear, it's symbolized by s, with the meter as the unit. In angular, it's symbolized by phi. It is radians. It equals with arc length s over pi radius, r. Speed is distance covered by the time taken to cover it. In linear, it's symbolized by v. It is s over t, with the meter per second as the unit. In angular, it equals with angular distance theta over by time t, with the radian per second as the unit. Velocity is rate of change of position, displacement over by the time. In linear, it's symbolized by v with a row above it. It is displacement s over by time. In angular, it's symbolized by omega. It equals with angular displacement phi over by time t, with the radian per second as the unit. And acceleration is rate of change in velocity over a given time. In linear, it's symbolized by a. It is velocity v over time t, with the meter per second square as the unit. In angular, it's symbolized by alpha. It equals with angular displacement omega over by time t, with the radian per second square as the unit. There is a relation between the angular and linear kinematics. First, angular to linear displacement can be formulated as s for linear displacement, theta for angular displacement, and r for radius. Angular to linear velocity can be formulated as v for linear velocity, omega for angular velocity, and r for radius. And the third is angular to linear acceleration. An object rotating has two linear acceleration. The first is tangential acceleration. It is tangent to the path, which is a t equals to angular acceleration times by r. The second is centripetal acceleration, which is directed toward the center of rotation. AC equals to omega square r or v square over by r. Remember, in angular kinematics, the angle counted in radian. So if we have the angle in degree or revolution, we need to convert it into radian. 1 radian equals to 57.3 degree. 1 revolution equals to 360 degree equals to 2 pi radian.
In the linear kinematics, we need to know some of the terms of quantities that play a role. First is displacement. It's the shortest distance between the final position from the initial position. Is a vector, has a unit of length. Second is average velocity. Is a velocity in between an initial time and the final time, while instantaneous velocity indicates what's happening at every point of the time of the motion. Is a vector, the unit is meter per second. Third is acceleration, is defined as the rate of velocity over a given time. Is a vector and the unit is meter per second square. As the ball falling down from the table is considered as linear kinematics, curvilinear motion. We can find out the linear kinematics quantities by this formula. V is final velocity, U is initial velocity, A is acceleration, S is displacement, and T is time. When the ball hit the ground, notice that the ball is bouncing back. but not as high as where it was dropped. The reason is simply as anything that is moving has kinetic energy. And the faster it's moving, the more kinetic energy it has. The kinetic energy formula is, and the unit is joule. Another kind of energy is potential energy. We measure potential energy of an object as its height above the ground. The formula of potential energy is, with the unit is joule. As it falls, it starts losing its potential energy and speeds up to get more kinetic energy. When it hits the floor, it has no potential energy but lots of kinetic energy. When the ball is touching the ground, as we said before, it still have a lot of kinetic energy, which where the velocity of the moving ball can we get from the equations of the ball is bouncing as the result of the quantity of motion of a moving ball, measured as a product of its mass and velocity, which we call as momentum. Momentum equation is mass times velocity, and the unit is Newton second or NS. Now we will talk about gauge cycle. One gauge cycle begins with heel contact and stop with heel contact on the same foot. One gauge cycle divided into two phases. First is stance phase and second is swing phase. Stance phase begin with heel contact on the right foot and stop at toe off on the same foot. Swing phase begin with toe off on the right foot and ends with heel contact on the same foot. Stance phase consists of 60% of gauge cycle, while swing phase consists of 40% of gauge cycle. We will talk about stance phase. It starts with initial contact. Loading response, mid stance, terminal stance, and press swing. Now we will talk about swing phase. It will start with initial swing, mid swing, and terminal swing.
ไม่อินิเชียลเซกเมนต์นะลมแรงมากสู้ๆเถอะสู้ไม่ได้ไหม3 ปีแล้วเพื่อนจริงป่ะ
Welcome to offline biomechanics course with the topic review Biomechanics 1.
2 3เฮ้ยนั่นแหละนั่นแหละ Okay. 3, 2, 1.
สวัสดีค่ะ Welcome to offline biomechanics course. สวัสดีค่ะ Welcome to offline